Okay, so welcome to the Rumble in English. This is the first Rumble we're doing in Israel, and we have chosen urban cooling as our first challenge, feeling that this is a very relevant time for this. We are super excited about this cooperation with Microsoft, and hopefully we will actually find some interesting and innovative solutions on this, when the idea really is to figure out relevant approaches and solutions for everything that has to do with the climate crisis, but when it relates to the urban environment specifically. I will give a few words on the competition in the next two sessions, and then we will hear from Dr. Tomer Simon from Microsoft, followed by a presentation from Dr. Or Alexandrovich from the Technion. And yeah, let me give you some words on what the Rumble competition is going to look like. We have two more additional sessions. We will invite you all to register your solutions by the 20th of the month. And we will choose 4 semifinalists who will compete in the next session, which is the semifinal session. And they will compete in 2 battles, and the 2 winners of these will go up and compete with each other in the final session. These competitions will take form of a ring, and each solution developer will be able to pitch their solution for 7 minutes and will be challenged with questions by a group of judges for another 7 minutes. The prize for this, the final best solution for urban cooling, will be awarded with access to the Microsoft Reactor in Tel Aviv, to be able to work there for a given period of time, as well as some support in grants, in handing in grants given out, and an opportunity to present their solution to the municipality of Tel Aviv. So I think that kind of sets that up. Like I said, please all go ahead and register your solutions by the 20th so that we have time to choose the best ones and have a great competition. Tomer, I'm going to hand it over to you.
Thank you and good evening. Excited to be here, especially around sustainability, urban heating, and just if we see the last 18 months with the COVID-19, 98% of infections were in cities, 98% of deaths were in cities. So cities are the major place where humanity happens and interacts, and I want to share just a few things about a program that Microsoft runs. So I'm Tomer Simon, I'm the Chief Scientist of the Microsoft Israel R&D Center. And a few years ago, Microsoft released a program called AI for Good, under which there is the AI for Earth, which is the program that I want to share with you in the next few minutes. And if we look at sustainability, it's not only an imperative for us to keep the Earth, it's also directly connected to the business and the profitability that we can make as a company and as a startup, and as everyone, we understand that this is the #1 priority looking forward. And what we are trying to do is, as you see here, decouple the environmental impact from the economic growth. We can minimize the impact, the footprint of the operations, and it's not only us as Microsoft, we are doing it. We have very strict 4 commitments until 2030 to be carbon negative, water positive, 0 waste, and of course create more natural habitats than are being ruined. And the idea is minimize the impact, but maximize the positive impact of the products, of the policies, of the partnership, and create a collaborative approach to tackle this human scale or planetary scale crisis. So what is AI for Earth? AI for Earth is a funding program or a grants program that enables everyone, really everyone, each and every individual or organization, whether it's a startup, a researcher, a company, to apply. And we're looking for innovative solutions to improve the way, as you can see here, monitor, model, and manage the Earth's natural systems. The program was launched in 2017 with $50 million. And we had also a year and a half ago an exposure event also in Israel, in Tel Aviv. In the previous reactor, in the location in Tel Aviv, more than 170 individuals and organizations came to see. And if we see the focus area, what is AI for Earth? So first of all, agriculture. We understand that people need food. And as the Earth population is growing, we have less and less resources and land. So we need to see how to feed this growing human population with a sustainable way that doesn't ruin, devastates the forests or any other habitat or even natural resources like water or vegetation or even any other open area that we use. The second one is water. As the population grows, we will need more and more drinking quality water. And this is, of course, if we look at the world, only less than 2% of the water in the world are drinkable. And out of them, it's very, very difficult, as you understand, the climate crisis, the scarcity of water, the water-stressed regions. So we need to see how to protect and replenish the water. The third one is biodiversity. Just if we look at the 20th century, 60% of all species we made extinct. We, the human race, made extinct. And in the coming less than 20 or 2 decades coming forward, the focus is that we'll make extinct another 40% of those that are left. And the last one, climate change. We understand that this is the planetary scale and human. The main crisis. You saw you know the Paris Agreement, you know the COP26, and so we understand that these are the 4 pillars under which the AI for Earth funds projects. So it's very, very simple, these grants. Anyone can apply. Just you get funds, credits to use the Microsoft technologies, the AI engines, and of course, part of the grants might be helping really even label data or even have Microsoft AI data scientists work with your group to develop and make sure that your solution succeeds. How it's a simple project proposal, and when you saw this was the last deadline, but the next one is in December, and together with Lanez, those that will win, we will be happy to assist the startup, the company, the individual, the organization to submit for the grant. And if we look at the last 3 years, already more than 700 projects around 100 countries that got funded. Okay, so it's highly engaging, it's highly successful, and next year Microsoft is going to inject more funds into the project. It's all about partnerships. So you can see technology partners, academic institutions, grant competition that we have with National Geographic, we have with the UN organization, you can see also with NOAA, and of course some signature projects that I don't have time to showcase, but really amazing, scalable and global projects. Just 3 short examples. So Sylvia Terra, again, it's an initiative how to use cutting-edge imagery, satellite imagery, to understand on a tree level, to map all the continental US, all the forest on the tree level, the single tree level that conservative government regulators could really understand how to plan and what are the effects and the impact of their planning on the trees and the forest of the US. Second one is example, wild bee. So this is called the citizen science. Most of us are going on trips, and scientists cannot map all the animals, how they migrate, where they are located. So using our smartphone and an app, you can be a citizen scientist and help scientists and researchers around the world to understand where the species, the animals are living, migrating and moving, and create this like crowdsourcing conservation of nature and of animals. And the last one is nature serve habitats. We want to make sure that governments and countries are able to rehabilitate lost habitat. And this is also a very nice project together with ESRI, the ArcGIS tool, to make sure that we can manage natural resources and reserve. Using this, just a year ago, we introduced and really showcased the planetary scale, and this is called the Planetary Computer of Microsoft, that enables all researchers. One of the challenges of climate and sustainability research is the availability of data and the availability of compute. Climate crisis became a big data problem, a big compute problem. So Microsoft created this planetary computer. It's connected to almost all of the regions of Azure, and the ability for researchers to really access all the data together and not do heuristics or guessing or forecasting or any compromises in the research, and the ability to afford everything. And this is the planetary computer. It's just planetarycomputer.microsoft.com. And it has huge amounts of data that are available to any researcher, also for you, for your solutions, for your ideas. If you need data, you can see the types of data: remote sensing, weather, land cover, external, and of course, your data that you can add and build solutions over it. I won't go over everything, but using this AI for Earth or your solution, and you can apply for access for this planetary computer. You have problems of classification, of forecasting, of planning, and of diagnostics of many types of ideas, solutions, and problems that you need, whether classify animals, pollution, air pollution, or water pollution, or any other contamination, forecasting landslides, flash floods, and of course planning resources and diagnostics of problems, of engineering, of leakages, of supply chains, of a lot of things, and everything is accessible. And I invite you to go and read about AI for Earth. And if we see that we live in urban, I won't have time to showcase, but there are more than 30 projects just in the last 2 years that came around urban challenges of sustainability. And I hope that you'll be able to apply and win, of course, the AI for Earth grants. And together with Lanez, we'll do our best to make sure that your potential probability to scale and use our resources together are improved significantly. So thank you very much, and do your best to keep Earth safe and healthy.
Wow, thank you, Tomer. Lots of potential. Wonderful. We will keep that in mind. And like I said before, the winners of the final session will receive some support to actually be able to access these grants. Dr. Alexandrovich is going to give us a short presentation about his super interesting and relevant work about shade in the sea. Please go ahead.
Okay, so I hope you see my first slide here, or not?
We see it. It's there.
You see it. Okay, so
Blood, sweat, and tears.
Yes. Okay, so we can start. Okay, so a very, very short introduction of myself. I'm an architect by professional training. I'm not a practicing architect anymore. I've been, but I left the profession about a decade ago, and I shifted my interests into the more scientific exploration of the relation between the built environment, climate, and let's say human behavior. And they're all connected, especially if you look at this specific subject of urban cooling. Now, the first question is, what is actually urban cooling? What do we mean by saying urban cooling? And the question is not very simple to answer, because at first you might think that we're interested in cooling the city or cooling the surfaces that absorb heat during summer, during daytime. But actually, I think the question should be rephrased in a way that we look at cooling not the city, but cooling the users of the city. And this is this makes a huge difference. And to try to rephrase it, we are actually interested in not lowering air temperatures, though it is important. And we're not interested in lowering air temperatures because we are, well, we are very limited in our capacity to do so. On the other hand, we can greatly and significantly change the way that we feel comfortable in the city in terms of thermal comfort. And in a minute, I will tell you what thermal comfort means. And the answer should first begin with understanding what affects our comfort and to understand what comfort really is affected by. And this is something that is not trivial, although everybody that you might think of would tell you probably that, well, it's hard or it's stressful during summer because of high earth temperatures. So the answer is not really, or this is only a very limited part of the answer. Now, what is thermal comfort? Well, it is correct to say that comfort is a subjective concept, that it is a kind of a state of mind. But considerable amount of research during the last century have shown that we can quantify and predict comfort based on objective and measurable climatic variables. And the most common comfort model that we use today actually are relied upon for objective climatic variables or quantifiable climatic variables that enables us to determine whether we experience any type of thermal stress. And the thermal stress can be cold stress, but it usually, and in the Israeli context, we are usually facing what we call heat stress. And three of these variables are very simple to measure. One of them is air temperature that you probably know. The other one is what we call relative humidity. This is something that people who are living in Tel Aviv maybe are more aware of. And the third one is wind speed that can, in a way, makes you feel a little bit better in hot days. But the fourth one is the most important one in Tel Aviv, at least, or in hot cities. And this is also the one that is the most tricky to quantify. And it is the one of total radiation load on the human body. And I will try to explain in a minute what radiation load means. Now, when we talk about radiation, we talk about two types of radiation that affect the thermal comfort. The first is solar light or sunlight. We also call it shortwave radiation, which we receive directly from above, from the sun, when, of course, we are not shaded, as well as from reflections from all kinds of horizontal and vertical surfaces around us when we walk in a city. And the other radiation type is that of heat. We call it also long-wave radiation, either coming from the sky or from or heat emitted from the surrounding surfaces around us. The problem is it is hard to estimate or measure this total radiation load on the body because of this inherently complexity of radiation coming from all directions and different amounts of it. And to do it in the most accurate way, or to measure radiation in the most accurate way, we should use a setup of several what we call radiometers. This is the equipment that you see on the screen right now. And by placing them in the right way, we can actually measure the amount of light radiation and heat radiation that we receive as a human body traveling through space. When installed together with a compact meteorological station, it is possible to get accurate measurements, not just of the radiation load, but of all other climatic variables that I've already mentioned. And then that means that we can use this equipment to actually get very, very accurate measurements of the degree of thermal comfort that we sense in different places around the city. This enables us also to understand which of these 4 variables that I talked about have the most crucial effect on comfort, or more importantly, on heat stress, especially during summer. These are many photos of measurement site that we were traveling through in the summer of 2020. It's me and Professor David Perlmutter of Ben Gurion University. And we tried to cover all kinds of urban situation and shading conditions, and to understand through this very big sample what really affects our comfort, or what really instigates extreme heat stress during summer. And the results were quite clear. This is the problem is the exposure to direct sunlight that makes you really suffer from extreme heat stress in Israeli summer conditions. And this has nothing to do, or almost nothing to do, with air temperature, or even not with relative humidity. And as an example, let's take these almost simultaneous measurements that we took in the same area, in the same location, which is Rabin Square in Tel Aviv. And you should look at first at the feels like figure. We recorded differences of about 9 degrees between shaded and unshaded locations here, while air temperature did not change much between each of these points. And this is because the air is constantly mixing, and this leaves any macroscale differences in temperatures practically unnoticeable. What is highly noticeable is the amount of radiation we're exposed to when moving out of the shade. This is really what makes us change from experiencing mild overheating during summer to high or even extreme heat stress. By the way, these differences are also or even more pronounced during the autumn and spring seasons that we are sort of into right now. As you can see from this example, this is from the beginning of December, and the difference is quite significant. And in the end, being exposed to the sun in an Israeli summer is not very different from becoming a human shawarma. The only way to prevent us from grilling is to block radiation from hitting our bodies. In other words, we should provide shade, and we should provide shade in a way that will actually cover us throughout our travels through the urban scape. Unfortunately, in too many cases, it seems that planners and designers do not really care or understand the climatic effects of their designs. And one common feature in Israeli public space design is the wish for zero shading. Not zero heating, but zero shading, as if every square is like a sunbathing beach in some exotic resort. And for a start, I think someone should first tell the designers this is not really the case, of course, at least not in Tel Aviv. Another problem lies in the misunderstanding of the term walkability. In Israel, to make a street walkable is not enough. To make a street walkable is not enough to design a wide sidewalk. This cannot be regarded as a walkable street. This is, by the way, Kaplan Street that probably most of you know. And without proper shading of this sidewalk, it is either a deserted public space during daytime, or is a source of daily misery for those who must walk along it or cross it. But this is actually only part of the problem. There is also a local trend of designing so-called shading devices, while forgetting that the sun positions in the sky is constantly changing, and that the provision of shade on a very specific point for 10 minutes a day does not count as proper shading. This is very common, and this is widely used by municipalities to show that they really care about the environment and about the climatic conditions inside cities. Fortunately for Tel Aviv, at least some non-designers were here first, and they actually understood the climatic value of shading even before climate change, and the role of trees in shade provision, even without relying on very sophisticated designs. While we do have some very good recent examples of clever and successful tree planting for shade, or even of some clever and effective shading elements, as you see here, usually we are left with quite bizarre designs that are so awkward and also ineffective. One must, I think, conclude that they were designed to increase awareness to the dangers of solar exposure. And sometimes we also just left with creative, so-called sculpting, tree sculpting fashions that are promoted by Israel's electric company. So we are actually stuck with very poorly designed streets and urban spaces that actually do not take into account the need for shade provision. So what can we actually do to promote change and to promote urban cooling? First, I think it's important to understand that change begins at the micro level of a single pedestrian, and that if you can provide adequate shade for him or her throughout their journeys across the city, you can actually change dramatically his or hers way of using the city. Now, I think this is what urban cooling should really mean, but where should we start? And for this, we have, in a previous study that we did, we have suggested a data-driven approach to mapping the hotspots of non-shade in Tel Aviv in a way that could reveal the shade hierarchy of a city and direct action to the places where shade is needing the most. And the result was a series of maps, and most importantly, shade maps, that show the degree of shading in each street segment in Tel Aviv. These maps are publicly available for browsing, zooming in and zooming out through this link that you see here. And of course, this is only a start. This is only the first step in using data, using geographic data and weather data, and some understanding of how the sun really works. Because it's a first step, I think it shows a direction, but I think it opens up many other opportunities. So to summarize, I think a major part of a solution is to ask the right question. So, and here the question might not be how to make a city cooler, but actually how to make city users cooler. And the answer lies here, at least in hot countries like in Israel, but also in these northern areas that are experiencing hotter and hotter summers and even autumns and springs. The answer lies with providing much more shade and understanding how to provide it, where to provide it, and who should benefit from it. Okay, that's about it.
Okay. Very important stuff. Oh, Aleksandrovich, thank you very much.
You're welcome.
I'm personally invested in this. It's very important for us to have enough shade in the city so we can continue to enjoy it. So thank you for that, and definitely the data-driven approach is when we're following. That's pretty much it for this evening. Again, we have the 2 more sessions. I invite everybody with a proposition or solution to go ahead and register it so that we can contact you all and choose the 4 finalists. And that's it. Thank you very much.